Okay, let's have a look at 5 equations of motion here that they can use to actually solve any problem where the object's doing a constant acceleration and it's going in a straight line. So the 5 choices are there, and you've got 5 different quantities that are involved in this. The initial velocity, v0, which is time 0. Final velocity at a time t seconds later, so towards the end of the motion, or at the end of the motion. Displacement is actually the distance travelled between 2 positions in a straight line, so it's the change in position. So think of that as distance, not speed. Acceleration is actually a, and t is time. So there are your 5 choices there. Okay. So if you just sort of bring this down here, you've got 5 choices there. Vt equals Va plus At, which means A times by t. S equals V naught t plus a half At squared. V naught times by t, half times by A times by t squared, just the t is squared. So just be careful of not actually making those mistakes and squaring the whole thing. The good thing about these is it will cover any question involving that straight line motion with constant acceleration. So this particular one here does not have the displacement in it. So if you had a question that did not involve displacement at all, that is the one you would use. If you had a question involving VT, sorry, not involving VT, you would use that one. This one here does not have VO involved in it. This one does not have time involved in it, and the last one does not have acceleration. So normally you can pick out which equation to use based on the 4 that you've got present and the one that's missing. So if you know you don't have time involved and you don't want to find time, you would choose this one here. So they're the 4 you can choose from. Okay? So let's just have a look at some of these here. If you had some examples of this. If you were told that a ball was dropped and takes 12 seconds to hit the ground, find the impact velocity. So you need to look at what quantities I've got there as a first step. So the first step is what quantities do I have? And you can answer this the same all the time. So in terms of the quantities you've actually got, you've been told it's dropped, which means the starting velocity is actually 0. And you have to sort of realise that for yourself. It takes 12 seconds to hit the ground, so that's actually a time, because it's in seconds, 12 seconds. We're being asked to find the impact velocity, which is the velocity after a certain time, vt. So we don't know what that is yet. So you've only got 3 things here involved, we need a 4th one. So the thing to realise about things that have been dropped is they've got an acceleration due to gravity of about 10 metres a second. And I'm going to put a minus there because it's going down, and we tend to call downwards motion negative and upwards motion positive. So there are your 4 quantities. The second step there is to actually select an equation. Now, to select an equation, as I said, you look at the ones you've got there and go, okay, I need an equation with all of those in there, but not the missing one. So the missing one is S. So if you look up here, which one does not have the S in it? It's the very first one. So I would choose the VT equals VO plus AT answer. Okay? And then you would actually substitute and solve as your third step. So substitute and solve. This technique will work for all of them. You just have to get used to finding which quantities you've got and choosing the right equation. So we're going to substitute and solve next. So underneath here you would actually just go and VT still as the unknown. That's your unknown. VO was 0 plus minus 10 times by the time of 12. So if you look at that, it's 0 plus minus 10 times 12 minus 120 metres per second. Okay, which means it would have a final velocity of 120 metres a second going downwards. Okay, so that's a fairly easy one because you did not have to rearrange the formula, but sometimes you do. Okay, so we had another question there, and it had something on the lines of a plane lands at the speed of 150 metres a second. And stops after a time of, let's give it 30 seconds, say. How far will it travel during that sort of landing period? How far does it travel on the runway? So looking at that, again, what we need to be doing here is finding the quantities first, step 1. So if you look at this, it's got a speed of 150 when it lands, and then it's going to stop. So the VO here would be 150. Okay. The VT when it's at the end of the motion is actually going to be 0. The time here they've given you as 30 seconds. And this time they're asking you to find how far it travels, which is that displacement value s. That's the distance, don't forget, not speed. So this time you're looking for an equation here which has not got acceleration in it. Okay, it's got those four quantities. So looking back up here, we're going to find without acceleration. So looking down the very last one, that's the one we would choose. It's got all four quantities, so we can solve for s, but it does not have a in it. So we're going to go s over t equals VO plus dt over 2. By the way, this comes from the average velocity, because average velocity is distance travelled over time, but it's also the two velocities divided by 2, added together and divided by 2. Anyway, substituting, s is going to be left alone, so that's our unknown. T is 30. The VO was 150. VT was 0. And you're dividing by 2. So there's a lot of ways of solving this. If you look at this side easily, it's 150 over 2, which is 75, is equal to s over 30. So to solve for s divided by 30, you would times by 30 on the other side. So leave the s there, leave the 75 there, and times by 30. And you get so many metres there. So 3, 7, 21, 22, 50, probably for that. I got that wrong, but that would be how far it travels. Okay? So just check that one out. Okay, thanks.